I love you, you love me, if we're related genetically. Today we're going to talk about the evolution of social behavior. I'll give you a clue. It's about being related genetically. Be able to define mutual benefit, selfishness, altruism, and spite, as well as social and eusocial. Be able to discriminate between social and eusocial species. Quantify relatedness, related to inclusive fitness. Calculate whether behavior should occur, whether it's altruistic or not, based on Hamilton's rule, and these are kind of waving your hand around calculations, not whip out a TA84 calculations. And describe the Greenbeard effect. So sociality. This is going to make sense to us. We are social creatures. We get along in social groups. Rejection does actually feel physically painful because our biochemistry has evolved to make rejection feel like physical pain. Why? It's something to be avoided. It's something that's going to release it, have less dopamine and such. So why are we social creatures? Well, it's driven by need for defense of mates and young. Those little creatures that are running back and forth in front of the window as I film this, they're relatively defenseless. But thankfully, we exist in a social neighborhood where we're all keeping an eye on them. Oh crap, is it my turn to keep an eye on them? Oh no. Anyway, we also have group living or cooperation between social creatures. Now I want to compare and contrast this with something called being eusocial. And being eusocial has very distinct things that will be needed. Whereas sociality is going to have group living, cooperation, sharing of resources, and can be very loosely organized, eusociality is most often going to be found in things like nests or hives. This is where you're going to get more than one generation living together, and the more than one generation are all in the same, nest or hive, really, honestly. They're also going to have cooperative care of the young. So, for example, we've got our neighborhood kids running around, and they mostly run in my yard because I keep my yard nice and clean. But that's not cooperative care of young. Eusociality, cooperative care of young, means all of the individuals, except the queen, of course, are going to be doing the feeding of the young that come from the queen. So there's a large devotion towards feeding the young, and it's cooperative even if they're not your young or even related to you. And the most signature one is the existence of sterile castes. So there will be some individuals who simply will not reproduce. And that kind of thing, where an individual is simply not having any fitness, but this is still a workable solution, is a signature of eusociality. So that's what you're going to be looking for, are those three things. Be able to give two examples or be able to compare and contrast with sociality. So what is social behavior? So we're going to look at definitions of social behaviors. There are 4 different types here, and we're going to kind of come up with an example for each one, defining these as different behaviors, and then be able to actually define which behavior is being displayed in this example. So it can be terms like this plus and minuses. What are they? Well, maybe in terms of fitness. Maybe this individual has an increase in the amount of fitness they have. They have more offspring. Maybe it's an increase in resources, which implies an increase in survival, which implies a resultant increase in fitness. Or it can also mean this minuses could be lost opportunities to mate. So perhaps they're going to be losing the ability to mate for a little while in order to increase the ability for another organism to have high fitness. That will be an altruistic behavior. First one would be mutual benefit. So mutual benefit. Let's take these green wood hoopus. So what happened? That was a cat falling into the next room. Anyway, I hate to see what she destroyed. Mutual benefit. These are green wood hoopus. And what happens is they're able to delay their reproduction to help their parents raise the chicks. So we see here the age of first reproduction in years. For the males will actually have a lower reproductive success in the number of total fledglings the longer they wait before their first reproduction. So those males that just leave the nest, quite literally, at age 1 are going to have reproduction of about 4, and those that leave the nest around age 5 are going to have a reproductive benefit of about 3. Whereas for the female wood hoopus, they actually have a reproductive benefit lower than 1 on average if they leave the nest at age 1. And they can have reproductive benefit up to 5 if they are going to stay around the nest for 5 or 6 years. One would imagine that there is going to be a certain maximum time before leaving the nest no longer really gives them any fitness benefit. But what happens here is are you stuck in there? She's fine. So the birds benefit by helping in raising the young. So that's actually going to end up benefiting the bird, the parent. It's going to end up also benefiting the child, because the child bird is going to have a greater experience later on in life. Okay, selfishness is really not the opposite of this, but different. Selfishness is a benefit to the self at the expense of the others. That's really helped me delete that part. Anyway, it's like these cane toads. These cane toads are going to be eating the eggs of other cane toads. So that's a great source of resources and a great method of population control. But what happens is the tadpoles that eat their brothers and sister eggs are going to grow faster, and they're going to have a higher benefit. So that's selfishness. Maybe not their brothers and sisters, maybe just other eggs. It doesn't really matter. I don't think they can really tell the difference. But what happens is they're actually specifically attracted to a scent given off by conspecific eggs. So eggs of the same species are going to actually make them get attracted. They're going to end up eating the eggs, growing faster. But that obviously reduces the fitness of other cane toads because they're being eaten by their siblings or by their relatives. It also reduces competition. Yeah, you're being a problem. You are being a problem. It reduces competition by reducing the total number of cane toads in the puddle. So stop being a problem. Altruism. Suppose if I were to go for plus, minus, this is a weird minus, plus, where the individual is sacrificing some parts of themselves or some resources of themselves or reducing their opportunity to mate in order to increase another. Now, altruism in nature is predicted to be resulting in negative fitness, because if you're going to risk your own resources, your own offspring, or your own ability to mate, that's going to decrease your fitness, and that would be selected against, of course, that behavior. But, it's not always really altruistic. Here's an example of a ground squirrel, and what it's doing is this loud chirping call to alert the other ground squirrels that there is a predator in the area. Now, the ground squirrels are more likely to give that chirping call if they're related to the other ground squirrels in the nest. They might even give a false chirping calls if they're not related to the other ground squirrels in the nest to kind of make them run away and give them more time to forage. So you're really saving, these are ground squirrels that are saving their relatives more than they'll save just any other ground squirrel. Like, consider, would you jump in front of a bus to save a kid? You're like, I'd like to, but I don't know if I want to. What if it's your child? Well, then yes. What if it's your twin? Well, then that's a good question. But if it's genetically the same as you there, that's actually an interesting question we'll get to with relatedness. But first, spite. So spite is another thing that shouldn't exist. Well, altruism shouldn't exist because it's negative to the individual. Spite shouldn't exist because it's negative to both. And this example here is that bacteria will sacrifice themselves to give off a certain bactericidal toxin. So they blow themselves up bacterially, and they secrete all this toxin into the environment, which prevents other bacteria that are hopefully not related to them from actually colonizing here. So here we have bacteria that when they come in contact with non-relatives, they whoosh, and they turn themselves into bactericides, and you see these neutral zones between certain ones here, but these you see how they're joining with others of the same strain. So that's an example of spite. Save yourself. No, don't save myself. Take out everyone with me. So there are the 4 different behaviors. Now it's hard to explain some of these costly behaviors because altruism and spite both infer serious fitness costs. You think these would not evolve because the individual that does these is going to have a lower fitness, and if they have a lower fitness, they're going to have lower contribution to the gene pool in the next generation, which should then have lower amounts of this fitness, or this behavior. This is kind of the story of the Good Samaritan, because as you'll read, hopefully you'll read this one, the Samaritan is not genetically related to the man who has been beaten and left on the side of the road. The people who are genetically related to him, the Levites and such, they ignore him. So the genetic relatives who would have gained anything are ignoring this guy, but this is a true altruistic act where the Good Samaritan is acting not only to benefit someone else, but to act in benefit to someone who's not genetically related to him. And that's where we're going to look at these behaviors in the term of genetics. Genetic relatedness should make most of these behaviors make a lot more sense. This is when an individual is going to benefit things that have the same alleles as them. And this is the idea of the selfish gene, that it's really the genes that are telling us what to do and the genes that are kind of telling us who to give our benefits to. And a good example of this is Hamilton's rule. Hamilton's rule simply states that you're going to be more likely to give benefits to someone who's genetically related to you than you would to a complete stranger. And this comes into something called kin selection, where there is a selection for individuals that benefit their kin or others that are related closely to them. And we get this equation, BR has to be greater than C. B here is a reproductive benefit to the recipient. R is the genetic relatedness between the two individuals. And C is the reproductive cost to the helper. So the cost has to be less than the benefit times the relatedness. So how related are you to an individual? Well, if it's 50% related, you'd expect the benefit to be twice that, at least, of the cost, because that's going to be multiplied by 0.5. So you'd have 1 should be greater than something less than 1. So it should be twice the size benefit compared to cost. And yeah, if you're 100% related, well, then you're yourself, and that's where your identical twin would be, I guess. 50% related is a sibling. So let's look at the numbers for this. And we're going to look at indirect fitness against direct fitness. Direct fitness is increasing offspring. So each offspring is going to have a genetic relatedness of 5. And that's in your standard sexual systems where both are diploid. So the standard relatedness of 0.5 between me and either one of my sons. I have a fitness of 2 because I have 2 offspring, nifty-50. It actually be a fitness of 1 because each is 2 times 0.5. Okay, there you get the idea. We're going to calculate indirect fitness. Indirect fitness, it's a relative's offspring. So if I have siblings, that's going to be 0.5. So it's a 0.5 if my siblings survive. So it's just as good for me to watch out for my bro as it is for me to watch out for my kidster. Of course, my bro can watch out for himself quite well. But his kids, should he ever choose to have them, he won't. Best you can do is dog. Just kidding. Anyway, siblings' kids should be 0.25 because they're 25% related to me. Grandkids are 0.25 because my kids are going to be 25% related to me, and cousins are going to be 0.125 because they're, you divide it 3 times. Speaking of my kids, they have been running back and forth in front of this window the whole time I'm giving a lecture. This is greatly hilarious to be talking about fitness and sociality because I live with these guys. I take care of them. I absolutely love them. And I would do a whole bunch of altruistic things for them. So that's that's who's running around out there. And they're going to have grandkids sometimes. But I want to keep in mind too. If only one of your children has only one grandkid, then your investment to that grandkid is all of your genetic relatedness, really, unless you have siblings who are having other kids of their own. So this actually is a fun lab to do that we are not doing in genetics, which is to go through wills and see what proportion of things go to each relative, and how the farther away you get, the less you get. Except for Aunt Mildred, who gave everything to the cats, which was bizarre. But anyway, direct and indirect fitness add up to inclusive fitness. So the direct fitness of your offspring and the indirect fitness of all your relatives and relatives' offspring, that is going to be your inclusive fitness. Oops. So let's see some examples of this in reality. We can see the examples of lions and lion coalitions. If 2 lions are related, then they're going to produce offspring. Both are going to benefit. If only one lion produces most of the offspring, the second lion still benefits. However, let's say that those 2 lions are going to be ousted from the pride by 3 lions. And let's say that third lion is maybe not related. Well, if that third lion is not related, he gains no benefit from the first 2 having offspring. So that's kind of a problem. So you wouldn't expect those to be unrelated. And what we see is males in coalitions of 2 or 3 are often unrelated, but anytime you get larger, you're going to be mostly related males because the third lion is not going to be getting a lot of offspring. The fourth lion is going to get virtually no offspring, and so you don't want to be that last lion getting no offspring. You want to at least have indirect fitness in this. Yeah, there's my direct fitness and my neighbors out there waving away. You want to have at least some indirect fitness in all of this. So you want to be siblings with the other lions who are siring the most cubs. Squirrel adoptions. This is kind of an interesting one. So inclusive fitness will drive adoptions. Squirrels will not adopt non-relatives. So if they have an original litter size that's relatively small, they're more likely to gain from having another squirrel kind of come on board. If the female squirrel gets killed or some way, shape, or form, a hawk or a bus, then she will adopt the young into her own litter. But if she's not related to the one who got run over, she's not going to adopt strangers. And this is really how squirrels decide whether or not to add another kitten to their litter. And those pet stories of like interspecies adoption, they're often driven by a lot of other factors, like the organisms being domesticated by humans, which is going to really mess with their neural wiring already. So yeah, squirrel adoptions are a good example. Here's another one, is greenbeards. And this is the idea that you're more likely to be altruistic to individuals who have at least some sign of being related to you. So let's say there's a gene for altruism. And that gene would actually be favored if the altruism was directed at others with that same allele. So this is what's called the green beard effect. So imagine a bunch of humans. The men can produce green beards. Oh heck, the women can produce green beards too. Why not? It's a perceptual trait. Anything really that is perceptible and can be seen. Hey, that guy's got a green beard. The trait's recognized, and I'll give help to those green bearded ones. What's going to happen is the green beard allele will increase in the population because I understand which ones are related to me, and I can directly give a benefit to someone with a known R. I know the R is at least something if I can see the effects outside, can see that in the phenotypes. So that would be the green beard effect. And we see this actually in slime molds. So slime molds have this life cycle where they've got a period of being free-living amoebas. When a situation gets bad, they're going to kind of aggregate. They form a slug. The slug moves, and if the situation's really bad, they'll form a stalk, and at the top there's a little mating ball, and they'll fruit off from there to make spores and go colonize other worlds. Well, except for the ones that go in the stalk. The ones that go in the stalk just die. So it's disadvantageous to be in the stalk. So you'd think that there'd be more cheaters. So cheaters would then become the entire thing. The problem is that cheaters that become an all no stalk just don't get held up. So someone's got to be the stalk. We would want to say that being the stalk should be selected against. And it is to an extent, but there is actually a punishment, and they're not allowed to aggregate with other amoebas because there's kind of a green beard effect where only amoebas that don't have the cheater allele are going to aggregate together and form a stalk. Some of them are going to end up being stalk amoebas, and the others are going to get to go free and all that. But they want to know that they're at least somewhat related and that they're not holding this dangerous cheating allele, which could cause the destruction of amoeba society. Slime mold society, sorry. It's a Fusarium slime mold. Okay, last, spite. Spite is taking yourself out and taking others out with you. It's cruelty to an extent where your fitness goes down and their fitness goes down too. So why would anyone be spiteful? It just seems so hate-filled. Well, something called negative relatedness. So let's say the population here has an allele frequency of 0.2. You have the allele, whatever allele that might be. A recipient, there could be two recipients. One is recipient 1 and recipient 2. Recipient 1 is heterozygous. Recipient 2 is homozygous for not having that allele. Well, the distance between your individual allele frequency and the population frequency for you is about, so I said that was 0.2, so that's 0.8. The difference for that recipient 1 is 0.3, and the difference for recipient 2 is 0.2, but in the wrong direction. Aiding recipient 2 makes the population more like him and less like you. Aiding recipient 1 makes the population a little more like you. So you actually want to harm recipient 2 because recipient 2 is not like you. And if recipient 2 has a benefit, that's negative relatedness. Your allele frequencies go down in the population if recipient 2 has offspring. And this is the idea that the relatedness is actually negative between these two because the population will change. This is where you get the idea that non-relatives shouldn't have nice stuff, or you get we don't want those people coming over here and swamping up our population because they'll make it less like me. That attitude might sound familiar. That is a spiteful attitude. And that is a very good political attitude to have, we've seen, because spite sells. Spite here in bacteria, though, it does actually have a cost, and it does actually have an adaptive, depending on who's receiving the spite. In the presence of a resistant competitor, where blowing oneself up as a bacteria is going to kill oneself, but has really no effect on the competitor, it's actually better not to be spiteful, to be benign, just kind of, I live, you live, whatever. So spite becomes adaptive, though, in the presence of a susceptible competitor, where blowing yourself up bacterially is going to actually get rid of the competitor and increase the frequency of your alleles in this area. So that's when spite can be adaptive. We see this as very much as a racism effect, too. Skin color can act as kind of an opposite greenbeard. That's not actually true for a lot of reasons, but it can be taken as the idea that this person is less related to me than other people who look like me. And this is where we see spiteful behavior that harms other races can be adaptive if it increases your genetic admixture in the population. Now, this is not a good thing. In fact, we know that this is not a moral thing at all. But this is where you see these sayings like bullets are cheaper than bricks. This was back when I was first teaching this a few cycles ago. We had a president coming in that wanted to build a wall. And people were saying, why build a wall when you could just shoot them all? Which is a spiteful behavior. And this is the idea of that reverse greenbeard, that these people don't look like us, therefore they're changing the gene pool. It's not a good behavior at all. It's morally despicable, but it does have its rationale in spite. So what type of behavior invokes the highest cost to both actor and recipient? How related are you to your cousin? What type of relatedness would make spite adaptive? And how does a greenbeard effect interact with Hamilton's rule? Be able to answer these questions, and you're going to be good to go. We'll come back next time and discuss a little bit more of relatedness and altruism.